Therapeutic, it is from the Department of Veterinary, Microbiology, Faculty of Veterinary Science and Medical Science, University of Pennsylvania, and the national statement therapeutic importance and safety assessment of equal extracts of Sargassum, crassifolium, and Ulva, lactuca, and moon healing. Waters are Premarathna, escape Wijesekera, Waduge, and RPVJ Rajapakse, represented by AD President.
Thank you, madam. Good afternoon, everybody. Our study is about therapeutic importance and safety assessment of aqueous extract of Sargassum crassifolium and lactuca in bone healing. Bone healing. A bone is physical injury that results in an opening or breaking of the skin. Bone healing is complex and orderly series of events, that is cell migration, alteration, differentiation, formation of extracellular matrix. Cells are marine, macroscopic, photosynthetic, and eukaryotic organisms, and they are known as cells. There are two types of cells: green, brown, and red cells. It has been shown that cells have biological molecules which are important in pharmaceutical industry. But in Sri Lanka, the biomedical potential of seaweed have not yet received much attention. Although there have been an enormous development in pharmaceutical drug industry, bone healing drugs are not still satisfactory because of their low availability, high cost, and various detrimental side effects. Therefore, a new treatment that can speed up bone healing may be more effective. It has been shown that plant extraction are widely used in topical application for bone healing and disease treatment, but the data on marine plants are lacking as medicinal. Therefore, our current study, we aim at investigate the healing properties in mice treated with seaweeds. Objective of this study. The overall objective of this study is to explore the potential bone healing properties of selected seaweed species available in Sri Lanka. It is also hoped to investigate the safety assessment by evaluating changes in hematological, biochemical, and histopathological parameters in experimentally wounded mice. Methodology. For this study, seaweed samples were collected from the south coastal algae bed in Sri Lanka. We mainly focus on brown algae, Sargassum crassifolium, and green algae, Ulva lactuca. This is how we make extract. Samples were washed 3 times in seawater, followed by tap water removed salt, sand, and liquefied attached to the surface. Aqueous extraction procedure. The seaweed were dried at room temperature until get the constant weight. Completely dried samples were ground to fine powder and sealed. The weight of the sample were taken. 250 of distilled water was added and vortex for 30 seconds. Aqueous mixture were placed in ultrasonic water bath for 1 hour. The sample were shaken in roller overnight. The sample were centrifuged and supernatant were taken for experiment. Experimental design. Experiment 1. Bone healing properties of selected seaweed. Experiment 2. Toxicological investigation. Mice were used as 5 groups. There were 10 in each group. Control group. Control group 1. Non-wounded animal and control group 2. Animal with wounded were not given any treatment. Treatment group 1 and 2. Wounded animals were orally treated with Sargassum crassifolium and Ulva lactuca respectively for 14 days. This is that we are used dosage. Treatment group 3. Wounded animal received topical application of water extract of Sargassum crassifolium ointment combination 3. Experiment 1. Evaluation of fruit extract of seaweed for bone healing properties in mice. Determination of bone healing properties. A circular area of full skin was used to create an excision bone model. The progressive healing chain were measured with vernier caliper on the day of the wounding and every 3 days until end of the experimental period. 2 animals for each group were subject to biopsies under heat at 3, 7, 10 and 14 days, and biopsies were then immediately immersed in 10% formalin solution. Histopathology. Tissue section were mounted and stained with hematoxylin and eosine strain and were used for histopathological evaluation. The depth and quality of granulation tissues were examined under the light microscope. Inflammation and proliferation phases of bone healing including bone contraction, re-epitheliation and granulation tissue development were monitored in the wounded tissue. Experiment 2. Toxicological investigation. The SGOT, SGPT and serum creatinine level were measured using commercially available test kit according to the manufacturer instruction. On the 14th day of the experimental, 2 mice for each group were sacrificed and vital organs were collected for histopathological and toxicological investigation. Same procedure was repeated on the day 17, 21st and day 28. Following the hematological and serological parameters were evaluated. Differential blood count, vaccine volume, blood glucose level and total serum protein concentration. The body weight also were noted. Behavior changes, food and water consumption of mice were recorded every 3 days throughout the experimental period. Statistical analysis. Graph pattern version 4.03 for Windows was used for all the statistical analysis. Research and discussion. Effect of the wound healing activity. The extract of Sargassum crassifolium showed the higher level of the wound healing activity within the 3 days compared to the control group. By the 40th day of the wound have been completely healed in treatment 1 compared to all other groups. From this graph showing highly wound healing properties, Sargassum crassifolium treated mice. Histopathology of wounded tissues and vital organs. When the weight of the organs of the sacrificed mice were compared, there were no significant changes throughout the experiment. Histopathological findings show that the aqueous extract of Sargassum crassifolium has enhanced the re-epitheliation and tissue granulation significantly when compared to control group. When considered the epidermic photomicrography treatment number 1, skin appeared well with rearranged epidermis and differentiated layers. Effect of the seaweed extract on SGOT and SGPT level. Both serum level did not show any significant change when compared with that of the control group. In the control group 2 and treatment group, serum enzyme and creatinine levels were within the normal range. Differential blood cell count. The study revealed significantly increase in the neutrophil and monocyte count in mice treated with aqueous extract of Sargassum crassifolium within first 7 days. As this table indicates, the vaccine volume in the experimental group did not show any significant difference when compared with the control group 2. Also there was no significant difference in the blood glucose level and total serum protein in all the experimental groups and control groups. Mice body weight. After the treatment group 3 mice exhibited highest average body weight compared with the other groups. These are the conclusions. Higher level of the wound healing activity was observed in Sargassum crassifolium when compared with the other groups. Histopathological findings also revealed that healing process was significantly fast in mice group treated with Sargassum crassifolium aqueous extract. Toxicity findings show that there is no toxic effect of the Sargassum crassifolium and Ulva lactuca water extract on mice. Liver is the major organ that is tested for possible toxicological effect, and there are no any considerable abnormalities in the liver tissues of the seaweed extract treated mice. Therefore, this study proved the wound healing potential of the Sargassum crassifolium, and further study are needed to identify active molecule in the extract through in vitro and in vivo studies. We thankfully acknowledge the staff of Animal Science Faculty of Medicine, University of Premarathna.